Today let's talk about series circuits. So the Merriam-Webster dictionary defines the word series as a number of things or elements of the same class coming one after another in spatial or temporal succession. The main takeaway from that definition is one after another. So if we place resistors one after the other, like this, then we have resistors in series. And then if we apply a power supply to resistors one after the other, then we have a series circuit. So here's a simple series circuit with 3 resistors in series. We know that the current originates from the positive terminal of the voltage source and travels around in a loop like this back to the negative terminal of the power supply. And since we only have one path for the current to take, there are no branches, there are no nodes in this simple series circuit, we know that the current will be the same everywhere. So that means that the current that's going through resistor 1 is equal to the current that's going through resistor 2 is equal to the current that goes through resistor 3, and that's equal to the current that was supplied and returns back to the power source. So this brings us to an important attribute of series circuits, and that is that current is the same everywhere in a series circuit. And this becomes helpful when we are asked to compute the voltage drop across resistors in series. So let me show you an example. So suppose we have, this time I'll put 4 resistors in series. And let's say this is R1, R2, R3, and R4. And then the voltage drop across the first resistor, we'll label that as V1. This will be V2, this will be V3, and this will be V4. And I'll label my source voltage as Vs. Okay, so the other thing we know about series circuits is that we can apply KVL around the loop. So if we start in a particular place in the circuit, we walk around this loop following the path of current and return to that point that we started. If we add up all of the voltages, assuming that we're following the passive sign convention, the sum will be 0. So for this case, if I start here, first thing I'm going to do as I come around my current loop in this direction is I'm going to enter this voltage source through the negative terminal. So that means this is going to be a negative Vs. And then the next thing I encounter is this resistor 1. So that's going to be a positive voltage drop V1, followed by positive voltage drop V2, followed by V3, followed by V4, plus V4. And if I add all those up, that sum will be 0. Okay, and this is by Kirchhoff's voltage law. Okay, so this means if I rearrange terms here, so if I bring this Vs to the other side, and I'm just going to switch this around just for aesthetics really, that means that Vs is equal to the sum of all the voltage drops around the series circuit. Okay, so that means that whatever source voltage we are hooking up to our series circuit is going to be divided amongst all of these resistors that are in series. Not necessarily equally, but if we add all these up, the sum of all these will equal V source.